Hi, my name is Bonnie Nguyen, and I'm part of the team here at EnSafe. We want to thank you for your interest in our Hazard Communication Regulatory Updates Review webinar, originally presented on May 12, 2025. We're excited to share this session with you. In this session, we cover the key changes introduced in the revised standard, including updates to labeling requirements, the safety data sheet format, new hazard classifications, and what these changes mean for training and compliance. This recording has been lightly edited for clarity and focus, but the core discussion remains intact. If you have any questions after watching, or if you'd like help applying these updates in your workplace, we are here to support you. I'll have our contact information on the screen at the end, so please don't hesitate to reach out. Thanks again for tuning in, and we hope you find this webinar both informative and helpful.
Hello, everyone. Thank you for joining us. And we're going to talk today about hazard communication. I'm Kristy Olive. I'm a CIH CSP. I graduated from the University of North Alabama. We had an accredited industrial hygiene program, and then I did my master's in business at UAH. But we have some other panelists here today. Joe?
Hey, good afternoon, everybody. Joe Hoffman. I'm based out of our Cincinnati office. I'm also a CIH and a CSP. I'm the service line lead for all things industrial hygiene at EnSafe. Graduated from the University of Cincinnati, and that's where I am still. So really excited to be here today and hopefully answer all the questions you might have. Thanks.
Okay. And we have Bayless Kilgore.
Yes, Bayless Kilgore with EnSafe. I'm Vice President of Health and Safety for EnSafe, and also CIH and CSP. And I want to thank Kristy, first of all, for putting this webinar on. I know it's going to be very interesting, and we're all going to learn a lot. I'm actually in Bowling Green, Kentucky, and went to Western Kentucky University, right up the hill from where I'm sitting right now. But glad everybody can join, and I appreciate it.
All right. And we have Ronnie Fulcher.
Okay, well, glad y'all all here today. I'm Ronnie Fulcher from the University of Southern Mississippi. I've been doing safety and industrial hygiene for right at 40 years now. So hopefully I can contribute a little bit here.
Okay, guys, we're going to get started on the hazard communication standard. And I don't know about you, but this kind of blindsided me a little bit. I was looking through in January all the new standards, and this one actually went into effect in 2024. And didn't catch it right away, but in January, I went to a webinar that the AIHA put on about the changes to the standard, and I thought, well, this is something that would be good if we shared with all of our clients and colleagues so that we could all know how things have changed. All right. So if you have been in safety for a long time, hazard communication, that was like the bread and butter. It was established in 1983, the original hazard communication standard, the right to know, we called it. And it was one of the first ones you learned about. It was updated in 2012 to align with a globally harmonized system. And at that time, that was revision 3. So that was an improvement. We'll talk a little bit more about that. But then more recently, there was another update in 2024. The new update aligns with the GHS Revision 7 to improve worker safety and information accuracy. Theoretically, it allows companies to send the same SDS to the United States and Canada. But Ronnie has had a little bit of experience with this, and apparently it is not as easy as the OSHA website may make that sound. So if you have questions about that and you put them in the chat, Ronnie will be able to help us out with what his experience was with trying to get US SDSs accepted by Canada. So we had the original one, and if you've been around that long, you know that those SDSs looked like absolutely anything. Some of them were a typewritten form that somebody had literally typed on a typewriter. Some of them were extremely professionally prepared and had tons of data, but they were not consistent. So in 2012, there was a revision to the hazard communication standard. And at that time, the big revisions, if you remember, were the introduction of the 16-section format. The 16-section format was a big improvement because before, everyone had this general guide that they used, but they might put things in all different places. So now you knew that section 1 was always going to give everybody the same information, section 2, and so on and so forth. We were all excited about that, and it made them all more consistent. In 2012, they also updated the labels. You went from some companies would have their own labeling, some would use an FBA. Anyway, people could use any kind of labeling they wanted to. So we went to the standardized pictograms. And the nice thing about the pictograms is that our workplaces are not always made up of only English speaking people. I mean, they may all speak English, but they may not be their first language. So the pictograms do at least give you some kind of a hint about what the hazard of that chemical is. So even if English was your second language, the pictograms do help with that. The new updated labels also included these signal words that tell you what the main hazard is for these chemicals. The hazard statements were standardized a bit, and the precautionary statements. And of course, the big thing was those pictograms, because they have a picture of what somebody somewhere thought the hazard was, but they're kind of standardized. It's a globally harmonized system, so everyone uses those same pictograms, which is very helpful when if your company is international and you have to convey information across different countries to different plants that do the same thing but in different locations. The regulations may change, but the hazards stay the same. Okay, so backing up, I'm sure that everyone here already knows this, but just to review this, what is hazard communication? We cover a few things in hazard communication. First of all, hazard communication is defined as the right to know. There was a time when I was young when people didn't know the chemicals they worked with. Now everybody is used to knowing what the hazards of chemicals are. They can get on the internet, they can get on Google, they talk about it in school, but at one time, you went to work and you did what you were told, and you didn't ask a lot of questions. So the 1983 standard gave employees the right to know what the hazards were of the chemicals they were working with and how to protect themselves from those chemicals. Why is that important? Well, because nobody is watched all the time. So if you know that somebody's told you to wear safety glasses, but you don't know why it's important, as soon as everybody walks away, you'll take off your safety glasses. If you're supposed to wear a respirator, but it's hot and sweaty, and you don't know what the danger is that you're going to encounter, then as soon as nobody's watching, you're going to take that respirator off. So it's important to safety and to people being consistent and following the requirements that are in place to protect them, for them to know why they're doing what they're doing. And the hazard communication standard tells us what the chemical dangers are, so that people don't just know do this, they know why you want them to wear that. They want to know why they're doing what they're doing, especially if it's uncomfortable. Of course, OSHA puts out the hazard communication standard. So from a regulatory standpoint, we have to follow it, right? What is the goal of hazard communication? We want to prevent injuries and illnesses. And if you've ever worked in industrial hygiene or ever worked in construction, you've probably encountered that guy that took the cartridge off of his respirator, stuck a cigarette through it, and began to smoke as soon as the supervisor wasn't watching. So we want to prevent those kinds of things from happening, because the people understand why I'm wearing a respirator. How did we decide that asbestos was dangerous? We're going to talk about an introduction to the globally harmonized system in a minute. And then one of the great things about the globally harmonized system is that it does provide a universal language for chemical safety. It gives us a way where we may not agree on everything about the hazards, but we can at least know this is a corrosive, or this is flammable, or this is going to cause problems for the fish in the water, depending on which symbol you're looking at. So one of the questions that comes up a lot when we get started talking about hazard communication is, I'm sure a lot of folks in safety had the same experience I did. I came out, I got a job in safety. The first thing they did was hand me this giant binder of safety data sheets. We called them material safety data sheets back then. And they said, your new job in safety is to keep this book up to date. And so that's where we started. We had this big binder and we had to keep this up to date somehow. So the first thing you do is you ask that question, how do I keep this book up to date? Well, you're going to have to make friends with the guys in purchasing and the guys in receiving, because you need the purchasing agents to request the SDSs, and you need the receiving agents to actually bring them to you so you can keep this book up to date. Never mind how many hours you spent back then making copies of these things and putting them in different departments. That was a really hard way to do this. You did that, you maintained your chemical inventory, and you did a lot of it manually, but thank goodness for technology, right? So first of all, you have to have a chemical inventory. So when I first started out, the way I would get a chemical inventory is I took my notepad and I walked out into the plant and I started in cabinet 1 and I started making a list of all the chemicals in this place because the plant I was at had not had one before. So we made a list of everything and how much we had of it. And we put all that information on a notepad. Then we went back and typed it up. Today, you've got all these other tools that are available to you. So your chemical inventory is probably maintained by you have some kind of existing inventory. And then when purchases a new chemical, they notify someone in EHS, probably electronically, and that automatically gets added to the system. So that's a great way to manage that allows you to be sure you've got what you need. The chemical inventory should include the hazards and the locations of the chemicals, which is the hardest part. I find that when I go to do an assessment at a site and I'm looking for their chemical inventories, they have an inventory of all the chemicals that that plant has, but sometimes they don't know where each one is used because somebody in purchasing may be maintaining that and they don't even know where it's being used. They just know I ordered it and they sent it and it had this SDS with it. So you've got several methods for maintaining a chemical inventory. You've got spreadsheets, you've got software, you've got lists, but if you don't have your purchasing and receiving people tied into that system, it's going to be almost impossible for you to maintain. And then you come into the bane of every hazard communication program manager's existence, and that is the P card. So I've got a procurement card, and then I run down to Lowe's and I get some more chemicals and I bring them to the site. Now that nobody has a record of those. So educating your supervisors and the people with P cards is very important. Hopefully your company has a ban on using P cards for chemicals. Maybe they don't. It's something to think about as you're putting your plan together. That inventory has to stay up to date. And as we said, keeping those purchasing and receiving people involved, that helps you keep that up to date. Next, you've got to ensure easy access to the SDSs. And the easiest way now is if it's electronic. There was a time when those big notebooks were everywhere. Now you go to a site and 9 times out of 10, there's a QR code somewhere that you scan. And when you scan that, it takes you to their SDS system. OSHA does allow for you to use an online SDS system for accessing SDSs, but here's the only caveat to that is that they have to be available anytime that there's emergency, anytime that an employee requests them. So if you have your SDSs stored on a local server, you got to have some kind of a backup. So that backup could be those big notebooks, or it could be a server at a remote location that's probably not going to lose power at the same time this location loses power. So you have to have a redundant system. So if you're using an electronic system, you still have to be able to hand those to the emergency response personnel or your employees if there's an emergency. You don't definitely have to do it one way or the other. You don't definitely have to have hard copies, but a lot of times your system, I used to use a system that would allow me to once a quarter print out a copy of everything in the system, but it took a lot of paper. So you have to have a redundant system. Either you need to have it on your server and then have a paper copy backup, or have it on your server and then there's somewhere on the cloud you could access it another way so that you could get to it in the event of an emergency. And then finally, again, binders, computer networks, mobile apps, all those things allow us to get the SDSs more efficiently than we used to do. So the key elements of the previous hazard communication system. So we've gone through an overview of the old hazard communication system. Material safety data sheets were great. They shortened the name to safety data sheets, and they provide detailed information about chemicals, but the old system had inconsistent formats. The labeling was somewhat inconsistent, and it mainly depended on how well your employees were trained on how to read an SDS. So the employee training in my early career would amount to me walking into a room full of steel workers and going over all the different types of chemicals on how to read an SDS with varying degrees of receptiveness on the other end. Under the old hazard communication system, we considered it a real treat that we could train on the hazards by hazard class. So we would talk about flammables and we would give some examples of flammables, corrosives, oxidizers, compressed gases, toxic materials, carcinogens. There were other relevant hazard classes, but we primarily, when we did a training class back in the 90s, we did a training class and we taught them generally what those categories were and told them where the SDSs were and told them that if they wanted to go and read one, they were certainly more than welcome to. But that wasn't very efficient at teaching people the hazards of the specific chemicals that they use every day. Because if the chemical is not going to be called corrosive chemical number 4, it's going to be called, it's a good example. The biggest example I can think of is we had a set of environmentally friendly chemicals that we used for cleaning at one of my jobs. And when the chemicals were diluted to the proper concentration and handed out to the employees to use, yes, they were very environmentally friendly, but they came in a concentrate. So a lot of those would be corrosive or flammable or an oxidizer when they were in their concentrated state. That was something that we had to talk to people about and train them on, because there's a big difference in something that's 50% ammonia and something that's 2% ammonia. So that was one of the things that we always had to address under the hazard classes. We can still train on the hazard classes. That has not changed, but we have some more tools in our tool belt besides just the hazard classes now. We now have all these pictograms. So these are just some examples of the pictograms. I'm sure you've seen them before. The explosives, the oxidizers, the organic peroxides, the radioactive, the flammable solids, and there are more. But this is some examples of some of the pictograms that are displayed on the labels and on the SDSs now. And the nice thing about them, again, they're fairly self-explanatory. I mean, even if you were not a person who read in English, you could look at that symbol and think, well, that looks like a fire. I better be careful with this chemical. So that's one of the things that this does. If you traveled to another country or to an area where they spoke a language other than English, you'd be very happy to have these symbols to let you know that this is flammable or this is a peroxide. Moving along in the years to 2012, we had to force ourselves to change from saying MSDS to SDS. So that was a big change for those of us that had spent 15 years using MSDS. Now we've got to say SDS. So if you hear somebody say one or the other, those words are interchangeable, except that the modern and current way to say it is SDS. They took off material. The 16-section format, the purpose of that was so that when you're reading an SDS, you can know where to flip to. So I spent a lot of time flipping through SDSs to look for components of chemicals, or to look for DOT information, or to look for PPE. And now that they're in a 16-section format where the same information is covered in the same section every time, it makes it a lot quicker. So if I'm looking for that disposal information, I'm going to flip to the back page because it's going to be on the back or the second to the back page usually. If I want to know what the concentrations are of the analytes inside the chemical, I'm going to look on the first couple of pages. So it's just helpful to be able to know where within the document to look for each thing and for it to be consistent every time. Back in 2012, the sections, you guys are familiar with these. There's identification, hazard identification, composition, first aid measures, firefighting measures, accidental release measures. There are more. We're not going to get into those because that's not the main focus of what we're talking about today. In 2012 is when we went to those harmonized signal words so that we have danger and warning. Danger is worse than warning. It's like when they come out to tell you that there's a tornado warning or a tornado watch. And you have to figure out, okay, one of those is worse than the other one. So they harmonize the words so that now we know that danger and warning indicate the severity of the hazard. Pictograms are standardized. The hazard statements are more standardized. The precautionary statements, that's the recommended measures to minimize the adverse effects from the exposure. The product identifiers is a unique name or a number used for a hazardous chemical on a label and in the SDS, and those have to match. That's important. The worst is if you have ever tried to look for an SDS and you have your product name and then you go to look for the SDS and you can't find anything that matches, and then the manufacturer sends you one and it's some vague category that you can't get it matched up with. That's not a good SDS. And then, of course, the supplier information, the name, address, and telephone number. So that brings us out of the review and to the new Hazard Communication Standard 2024. Did a lot of Google searches on this to find out more about it, and it seems to commonly be referred to as HCS 24. So if you're looking at something that says HCS 24, pretty good chance that they could be talking about the hazard communication standard as it was updated in 2024. What are the main changes? And this is probably why you signed up, right? Under hazard classification, they have updated the classes of skin, corrosion, irritation, serious eye damage and eye irritation, and flammable gases and aerosols. They've updated those classes to have more specific descriptions. We won't get into how to write an SDS today, so we're going to talk a little bit about some of those changes, but we're not going to get too deep into it. There is now a new class, desensitized explosives. Non-animal test methods were added for skin and corrosion irritation. So those were they changed a lot of the changes were to how you write that SDS and how your chemicals get classified if you're a manufacturer. Then we move on to labeling requirements. And this was, I felt like this was a good one. This was my takeaway of which was the best change that we had. For small containers, they have new provisions for containers less than or equal to 100 milliliters. And for very small containers that are less than or equal to 3 mils, you've probably bought one of those tiny bottles of some chemical like whiteout or something. And the label is wrapped, if you can pry it loose, the label is wrapped around the bottle 4 times because they have all this information and it's so tiny, you can't possibly read it, even if you can get it all rolled out properly. So they have changed some of the labeling requirements for the very small containers to allow you to have fewer words on there so that they're larger and you can actually see what you're reading. There is some increased flexibility in labeling chemicals that are already released for shipment. So in other words, they didn't make people call them back and put new labels on them. And then bulk shipments, updated labeling for chemicals in tanker trucks, rail cars, and intermodal containers. So those all apply if you are shipping chemicals. So that's for manufacturers of chemicals. If you are receiving chemicals, it's not on you. I mean, you have to verify that the labels stay intact, but it was on the manufacturer to make sure that the labels were proper in the beginning. And then finally, safety data sheets, sections 2, 3, 9, and 11 have been updated, and they have changed their rules regarding the trade secrets. If you have a trade secret, they used to be able to put on that SDS between 10 and 70%, which told you absolutely nothing. So they have changed that to tell us some ranges that are allowed, and they're a little tighter. So you don't get that one that says, well, this chemical has between 10 and 50% sulfuric acid in it. Well, that's not very helpful if you're trying to keep your people safe or if you're about to fight a fire. So they have reduced those ranges so that it's more informative to the person reading the SDS. And then they revised the precautionary statements. And the goal of that was to improve readability. You've probably seen that there was a study back 5 or 10 years ago where they determined that people were writing things in a way that just sounded complicated and didn't use plain language. So they passed the Plain Language Act, which says that, you're supposed to use something that most people could read and understand. This isn't completely like that, but improved readability and comprehensiveness for the person that's actually going to be reading that versus an EHS professional that handles these SDSs all the time is an improvement. So we've talked about globally harmonized system. We've looked at the pictograms. So what matters? Why did they care about aligning with revision 7? Because OSHA's not generally known for staying up to date with the latest revision of different things. We were on revision 3. We updated to adopt revision 7. The goal there was to be more consistent with international standards. And the goal was, in some cases, for someone in the North American area to be able to create an SDS that would work for both US and Canada because it was the same language and they were both using the globally harmonized system. When you get into practice on that, Ronnie ran into that a little bit. Sometimes it's a little tougher than just writing it to meet the US standards and then getting it accepted by Canada. So there's a little more to it than that. But if you have any questions after the class on how that process works, if you've got companies in both countries that are manufacturing the same chemical, Ronnie's got some tips and tricks that he learned on how to do that or how not to do that maybe. We said that the hazard classification, and this is again in writing an SDS, they've updated the classes for skin and corrosion and irritation, serious eye damage and eye irritation, flammable gases and aerosols. They added the new class of desensitized explosives and they've added non-animal test methods for corrosion and irritation. One thing I always need is better concentration, better focus, and the hazard communication standard has tried to help us with that. You can see these bands. So we've got, this is not all the bands because it would have taken 5 slides, but less than 1%, 0.1% to 1%, 5 to 10%, 7 to 13%, 10 to 30%, 65 to 85%. These bands are much better at telling you how much of that chemical contains a particular analyte than the old system of just, well, yeah, it's a trade secret, so we're only going to tell you that there's between 5 and 95%. Now you have these bands, and these bands should better help you characterize, if you're reading the SDS, the level of hazard based on concentration. This is the one I was excited about because if you work in laboratories and you have these tiny bottles that you have to deal with of some chemicals come in tiny bottles, and we're happy that they do because that means it's not going to cost us a fortune to dispose of what is left over at the end of the project. But the problem was, okay, so I've got this tiny bottle and now I need to label it. The writing on those would be so tiny that you couldn't even read it. So now they've changed that. If it's less than 100 milliliters, you still have to have the product identifier, the signal word, pictograms, the manufacturer's name and phone number, and a statement indicating that the full label is on the outer package. If it is a very small container, which is a less than 3 milliliters, practical accommodations allow for minimal labeling elements due to space constraints. And for that, from what I've been able to find in the interpretations and the training they've offered on the website, you still have to have the product identifier. You have to have the signal word and pictogram for the the primary hazard. So if something is a carcinogen and it also is an eye irritant, then you're probably going to label it as a carcinogen rather than an eye irritant, because the most serious hazard or the primary hazard would be that it's a carcinogen. So they did have some caveats in there for the chemical manufacturers. If they had already released some things for shipment, they could still leave the original labels on them. They didn't have to call them all back and relabel them under the new labels before they could continue shipping them out. And then for bulk shipments in tanker trucks, rail cars, intermodal containers, they must have labels on the immediate container or transmitted with shipping papers, bills of lading, or electronically. And the labels must be immediately available to workers in printed form upon receipt. I've got a small focus on laboratory labeling. And this is, again, the challenges of labeling in laboratories, those small containers, frequent transfers, a variety of substances. You stick to those basic labeling requirements. You've got to have the product identifier, the hazard warning, pictograms, signal words, hazard statements, and precautionary statements. Remember that the label must withstand laboratory conditions. So if it's an acetone bottle and you label it with a Sharpie, as soon as the acetone spills onto it, it's not labeled anymore. So depending on what the chemical is and the environment you're putting it in, the labels that you put on have to withstand the normal laboratory conditions. Best practices for labeling in laboratories include using durable chemical resistant labels of an appropriate size, ensuring clear and concise language, securely attaching the labels, and updating them when you're transferring chemicals. And there's a lot of challenges with that, but the main thing is for it to be legible. All right, the new safety data sheets. So we had the old ones, and then we had the new 16 section. Now we've got these new ones, and it looks like Bonnie's got a poll question for us.
Yes, so the live poll question is, which section of the updated SDS do you find the most confusing or challenging? And it looks like most people answered section 11. Toxicological information section was the most challenging or confusing.
That one is the toughest. So if you look at section 2, the changes there, that's where hazard identification is, and that's changed because the GHS classifications have been changed. Your label elements, your precautionary statements have been updated. Your section 3 composition information on ingredients, that has changed in that they've now got those bands for the concentrations on trade secret chemicals. Chemical properties, they have changed a little bit of the testing on this. Key properties such as boiling point, flash point, solubility. If you are going to write an SDS, it is well worth digging into the new requirements for how to write an SDS. That is not just like it always was. There's a really good AIHA 4-hour update on the hazard communication standard that really gets into writing an SDS. that I really enjoyed. That gets us to section 11, which is the toxicological information. So that's supposed to tell us the health effects, exposure routes, and the symptoms to know how the chemical is going to affect your body. The thing that we have to keep in mind when we're interpreting that section 11 is that unless you are a physician, you're not a physician. We read these health effects as an industrial hygienist, as a safety guy, as a supervisor, and it says this chemical can cause shortness of breath, jaundice, whatever. Those are warning signals that tell us that a person's experiencing this, it could be coming from this chemical. If they're having those kind of effects from the chemical, we need to refer them to medical care so that a doctor can determine whether this is actually the cause of what's going on with them. We cannot make a medical diagnosis. As EHS professionals, that's not our job. Medical professionals, that's a whole different category. If you are a medical professional, then you can make those calls maybe. And you can do that with the input of the EHS professionals that can tell you, okay, this is how much they were using. This is the data we have on that. But most of that toxicological information is gathered in labs. It's based on research where they determine the LD50 and the LC50. And if you have questions about LD50 and LC50, I know that the guys in the chat can answer those. In the interest of time, I'm going to keep moving. These are the precautionary statements that are meant to keep things clear and minimize prevent adverse effects. The point of the change was that it's improved readability. Say that 3 times fast. They have simplified language, consistent formatting. They're meant to be comprehensive. They have more expanded instructions, specific scenarios, such as this is what we do in an accidental release versus this is what we do during normal usage. They align with the GHS. The goal was that they be globally consistent, and then we use those updated pictograms. So when did all this happen? While I was sleeping, I guess, because it was effective July 19th of 2024. And then they had to, by October, they already had to issue a bunch of corrections because what they implemented in July of 2024 had some issues. And so they issued some corrections in October 9th of 2024. The compliance dates and requirements for updating the labels and SDSs if you are a chemical supplier was 18 months after the effective date for substances. You might be able to argue with OSHA if you got them done by 18 months after October instead of July. That would be something to talk over with your local compliance person. The training requirements under the 2024 standard say that employers must provide training to employees on hazardous chemicals in their work area. The training must include the new label elements and SDS format. For example, a training session on recognizing the new pictograms and understanding updated SDS sections. So ideally, when you're doing that kind of training, you want to tailor it to the chemicals they're actually using. You don't want to just be like, hey, there's changes, and not tell them what the changes are to the chemicals they're using. You want to review the new SDS and the old SDS yourself before you do the training so that you can determine what might have changed and educate your employees on the changes to the SDSs. Obviously, hazard communication training is important. It's how we inform people of what kind of chemicals they're working with and how to protect themselves from those chemicals. In keeping our training up to date, we cover new SDSs, label elements, new hazard classes, and accessing SDSs. And that's one of the big ones because when everybody had a giant yellow notebook on the wall, it was pretty easy. You just kind of pointed at the wall and said, okay, there's the SDSs. If you want one, go get it. Now that you have an online system, you do have a duty to your employees to teach them how to access that on the system. Maybe your system is as easy as scanning a QR code with your phone and it automatically pulls up the SDS, but most of them are not quite that simple. Most of them require multiple steps, and different employees have different levels of technological ability. Teaching them to access those SDSs is important. Putting them out there on the internet and then not telling them how to get to them, that doesn't really do anybody any good. And then finally, finding information on new chemicals with unfamiliar hazards. So if you bring in something into your site that is different And I can tell you right off the bat, the ones they're going to ask about are the ones that smell. If you've ever if you've ever worked in a plant as an EHS person, if you bring in something that smells different, everybody's going to want to know what the hazards are. I think Bonnie has another question.
Yeah. Hopefully you guys can hear me this time. So how is your organization planning to train employees on the updated HCS? It looks like most people are going to do online training or e-learning. The second one is in-person classroom or on-site training. And the third is the toolbox talks or safety meetings.
And I would say that some combination of those is actually the best solution. That online training is great for conveying the general information about the standard. It is great for teaching you how to access an SDS, because if you can have them click through a couple in your learning management software, they're going to know how to find them in the future. Where I think that it helps to have the in-person training and the toolbox talks is when you're talking about that specific chemical. If you're, I worked in the metals industry for a while, and we had hot metal, and we had to write on it with these markers. I didn't have to write on it. The employees had to write on it. And we had one type marker, and they were using them, and everybody was happy. Then they got a new type marker that was cheaper, and they would write, and the marker would, first of all, it had a tendency to melt, and it smelled horrible. So when you're making a change like that, that doesn't seem like a big deal. If you're sitting up here and it met the specs, and you're sitting in purchasing and it met the specs and it's cheaper, so we're going to buy this new one now. That kind of thing will impact the efficiency of your operation as well as your safety more than you might think. Because if you have a change like that, and all of a sudden now people have wax melting and coming onto their hands, or it smells horrible and they just can't stand it, that's definitely going to cut down. You're going to have a lot of chatter. So those are good for toolbox talks. We've got this new marker. We're going to try it out. Just telling them ahead of time instead of just dumping them into their workspaces goes a long way, not just on safety, but on building a good relationship with the employees as well. What are the advantages of the new one, the new standard? It's supposed to improve worker protection, safety with clear hazard information. And I think if we execute it properly, it will do that. Enhanced readability and comprehensiveness of the labels and SDSs, better alignment with international standards, flexibility in labeling for small containers and bulk shipments. So those are the good takeaways. What are the disadvantages? Well, it's going to cost companies something to have to update all their SDSs to meet those new standards. Not just everyone writes SDSs, it's a process. It's important if you are a company and you know about this new standard and you produce chemicals that you have budgeted to have your SDSs updated. Training requirements for the new employees. Anytime you have to retrain all your employees, that takes time, and that's always the biggest commodity each company has is the time of its employees. And then there could be a potential confusion during the transition period. So I think in this case, and again, this is only my opinion, I think the advantages outweigh the disadvantages for this particular standard update. If you want to learn more, OSHA's website has quite a bit of information on the update to the standard, GHS, and quite a bit of update letters and information for helping you communicate this to your employees. NIOSH and the Chemical Safety Board have additional resources. There's nothing better when you're giving a safety meeting than going to the Chemical Safety Board YouTube channel and seeing if you can find where they actually investigated an incident and it ties back to something that's going on at your facility. People will watch those and they will really get involved and ask questions because they will do an instant investigation of somebody that was real. And a lot of times they'll interview their families if it was a fatality, or they'll interview the people if they were injured. So those are very helpful. Of course, we got the OSHA's hazard communication standard that you can look at. And then OSHA's final HCS rule is available on OSHA's website as well. And it's important to remember that hazard communication is a shared responsibility. Employers provide information and training. Employees actively participate in safety practices. And employees help by reporting damaged or missing labels, asking questions about chemicals, staying informed, staying safe, looking out for each other, and employers build that trust by answering those questions and not minimizing the concern of employees. Because you may have been working with this chemical for 20 years, but if you have a new employee and it's new to them and they've never even been in the type, this is their first 6 months and they ask questions, it's important to validate their questions and make sure you give them solid answers as they begin their careers. When I built this presentation, it's been a minute, but I was looking at the OSHA appointees for 2025, just because things change and things have changed a lot in the last few months. So I looked up in the OSHA's website, and these were some incidents that they had more information on. OSHA's National Safety Council has a Road to Zero coalition to join initiatives to prevent fatal workplace motor vehicles incidents. And you can read these if you are interested in them. They are all available on OSHA's website. And I found when I was doing this research, OSHA puts out these quick takes, and they seem, if you've been doing safety for years, they seem real obvious. But the nice thing about those is that if you have a multilingual workforce, they put those out in different languages. So if you have a multilingual workforce and you want to get those in Spanish and be able to post the same thing in English and Spanish for your workforce, they put them out in both languages. So that's very helpful sometimes when you are doing toolbox talks, especially. According to the website, they have updated the cost of noncompliance. Serious violation, they could charge you up to $16,550 per violation as of 2025. They don't always do that. And Ronnie has been talking to some of the guys at the local OSHA office, and he can probably offer a little more insight to that after the class if you have a question. But it gets really expensive, especially if you don't fix the things that they put in the lists, because then you start getting additional charges per day, another $16,550 per day beyond the abatement date. Willful or repeated violations, they multiply it by 10 times. So it's important to, if you're trying to do cost benefit analysis and justifications to your company for why we need to do this training or why we need to buy this safety equipment, this can get really expensive really fast. Finally, I just wanted to point out that OSHA has an outreach training program. They offer OSHA 10s and OSHA 30s for construction, maritime, and general industry. And you can get trained or become a trainer or find a trainer on OSHA's website if you have just need for general OSHA training. And I was a little long, Bonnie. Do we have room for our panelists?
So there was a question in the chat, and someone asked, is the HMIS labeling system no longer allowable for labeling of secondary containers?
Yeah, so I just typed a response in the chat, so they'll continue to allow NFPA or HMIS labeling. For workplace labels, they still have the same flexible approach as long as you're communicating all the information that GHS or Global Harmonized System would requires, then HMIS would still be acceptable as long as it doesn't conflict with any other labeling or SDSs.
Yes, agree. And the most important thing is if you walk around and ask different employees, maintenance staff, or whatever, what the labels mean, that they can clearly answer and that they understand them. So it's more about the effectiveness than it is the type of label, at least as OSHA allows it for now.
And this concludes our webinar. Thank you for watching this recording of our Hazard Communication Regulatory Updates Review webinar. We hope the content helped clarify and inform you about the key changes in the 2024 Hazard Communication Standard. If it didn't, please don't hesitate to reach out. We want to make sure you have what you need to stay informed, stay compliant, and stay safe. If you have any follow-up questions or are interested in additional training or support, the EnSafe team is here to help. I know from our pre-webinar survey that many of you identified your biggest challenges as keeping SDSs up to date and accessible and improving employee training and information retention. These are areas where we can absolutely support you. So please don't hesitate to reach out if you'd like to continue that conversation. We appreciate your time and we look forward to seeing you at a future webinar.